This video is going to walk you through factoring trinomials, which is essentially the opposite of what we just did in the last two videos where we were expanding and simplifying binomials, so multiplying two binomials together. So what that means is that we are trying to go from this form and we're trying to get something that looks like what we had before. There. Where it looks like something like this with brackets, and we have an x plus or minus a number, and another x plus or minus another number. So just like in the last videos, I'm going to show you three different ways, and then I'm going to work through a couple of examples each way. So I'm going to start with this example here. So we have y equals x squared plus 5x plus 6. And just like before, the first way that I'm going to show you is using algebra tiles like this. So we have x squared. Oh, everything is very slow for some reason. Very laggy. So we have x squared plus 5x plus, let me just double check that number, plus 6, I believe. Yeah. X squared plus 5x plus 6. So last time we started by making them kind of look like this. We put them in two rows. This time, instead of starting with that and then filling in this rectangle, we're actually starting with the rectangle, and then we're going to find out what those two rows are going to look like. So I have, oops, I'm missing a one here. I have x squared, the big square one, and I have 5 x's, the green ones, and then I have 6 ones. So I have x squared plus 5x plus 6. So what I need to do is try to turn all of these things into a rectangle. So I'm going to drag these around and try to make everything into a big rectangle. So I can start with something maybe like this, and I see that I have a rectangle, but I'm still missing these 6 ones, and they have to be included in the rectangle. I can't just leave them out. So all of these parts have to be included, and somehow it needs to make a rectangle. You may be noticing that it's not really going to fit very well, because if I do something like this, I'm missing a piece of the rectangle up here. So this is still not quite right. And if I play around a little bit, I could maybe try flipping some of these, rotating some of these. So it goes vertically instead of horizontally. But then I have 2 extra pieces. So maybe I'll try rotating one more. Put 2 of them up this way. And then we get a rectangle. So this is what we're looking for. So now what we need to do is, we talked about common factoring in class. So what we need to do is find the greatest common factor in each column this way and each row this way. So the greatest common factor here between x and x squared, we can take out an x. And then here, the greatest common factor when we have this, which is 2x, and this, which is just 6, the greatest common factor there is a 2. So at the top we have x plus 2. The greatest common factor in the first row is an x squared with 2 x's, so the greatest common factor there is an x. Down here we have 3x, and we still have these 6 ones here is 6. Greatest common factor between these two is just a 3. So what you may notice is that there are 2 columns here, and that gives us a 2, and there are 3 rows this way, and that gives us a 3. So when we factor x squared plus 5x plus 6, we get x plus 2 in one of the brackets, and the other bracket is x plus 3. The order I write these in doesn't matter. I could write x plus 3 first, and then x plus 2 second, and that's totally okay. And I could have made the rectangle the other way as well and had 3 columns here with only 2 rows here, and it still would have worked out okay. Back over on our Jamboard here. 1 second while the screen stops freezing. don't know why it's so laggy today, but that's all right. So let me erase all of this. Okay, so back over here, I'm going to draw the algebra tile. So I had an x squared, so that's the big square, and then I had 5 x's, and what I ended up doing was putting 2 here and 3 down here. So I have x squared, 1, 2, 3, 4, 5 x's, and then I have 1, 2, 3, 4, 5, and 6 of those 1's. So I end up with x squared plus 5x plus 6, which is what we have here. And then you can take the greatest common factor here, or look at the width of it. It's the width of one of these x shapes. Here, the width is one of these and one of these, or a 1 and a 1. So plus 2. This way, again, we have an x, and then with these 3, we can factor out the 3. So we end up getting x plus 2 times x plus 3. The second way is using this method, or the area model. So we always start with taking the x squared term and putting it in this box. And we take the term with no x's and we put it in this box. And then what we need to do is we need to find two numbers that are going to fill in these two boxes. Both of them will have an x next to them because we're taking this and essentially splitting it into two pieces that we can put here and here. Kind of like we did over here with our x tiles, we split 3 of them here and 2 of them here. But we have to figure out why there's 2 here and why there's 3 here and why it doesn't work some other way to give us this rectangle like over here. So these two numbers, when we multiply them together, they need to equal 6. And that's that last number here that doesn't have any x's with it. And when we add these two numbers together, it has to equal this number here that's in front of the term with just the 1x. So they need to multiply to this, and they need to add to this. So this is a positive 6 and a positive 5. So positive 6, positive 5. So if we think about the factors, which we talked about in class, the factors of 6, I could multiply 1 times 6 and get 6. But if I add those together, 1 and 6, I'm not going to get 5. I'm going to get 7. So that won't work. Another option would be to multiply 2 times 3. 2 times 3 gives me 6, and 2 plus 3 gives me 5. So those are the numbers that I need, 2 and 3. And once again, I need to take the greatest common factor in each column and in each row. So here, the biggest number I can factor out is just a 1, because there's a 1 here and a 3 here. And then I can take an x, because both of them have an x. Here, the greatest common factor here would be a 2, because both of these numbers are divisible by 2. This one has an x and this one doesn't, so I can't take any extra x's. That's a positive 2. Here, again, greatest common factor is x, and then here the greatest common factor is 3. So you'll notice we got the same numbers here as we did here. X plus 2, x plus 2, x plus 3, x plus 3. So when we factor this, using this other method, we get exactly the same answer. And if I had written these in the opposite order, with a 3 first and a 2 first, that's totally okay. And if I'd written the 3 here and the 2 here, that's totally okay. It's still going to work out and give us the same numbers. And it's okay to write x plus 3 before we write x plus 2. Absolutely fine. The final method, I've abbreviated to MAN. So this is the MAN method. Essentially what we did here, but without writing the box of this. So M stands for multiply. We need two numbers that multiply to this one. The one that is just a number. Just a number. No x's with it. Or maybe I'll write it that way. I think it's frozen again. to multiply to whichever number is here that has no x's with it. No x's. And we need to add to the one that's in the middle usually. If it's written correctly, usually the x squared is first, and then the one with the x, and then the one with no x's. So the one with no x's is what we need to multiply to, and the one with just one x is the one we need to add to. So we need two numbers that multiply to 6, and two numbers, those same two numbers, that add to 5, because it's the middle one. And n, of course, stands for numbers. So we're looking for what these two numbers are. So we already found them over here using this method. So we already know that the correct answer will be 2 and 3. And they can be written in either order. So I'm just going to flip the order and show you that that works as well. Once we have these numbers and we've checked 3 times 2 is 6 and 3 plus 2 is 5, excuse me, then we just plop them in the boxes. So each